Welcome back to Think Cosmos, where we ponder the universe's deepest secrets and wonders. Life finds a way. It's a classic line from Jurassic Park, referring to dinosaurs. But it turns out it even applies in NASA's ultra-sterile spacecraft assembly rooms. Imagine a laboratory so clean that technicians wear full body suits. Air is filtered to the extreme. Every surface scrubbed relentlessly, all to ensure no Earth microbes hitch a ride to Mars or the Moon. You might assume nothing could survive this onslaught of cleanliness. And yet, scientists just discovered dozens of new microbial species living happily in a NASA clean room. Yes, in one of the cleanest places on Earth, life not only persisted, it thrived enough to evolve into new forms. This surprising discovery is teaching us about life's tenacity and forcing space agencies to rethink how we keep spacecraft truly clean. The discovery: 26 new bacterial species in a NASA spacecraft facility. The specific clean room in question was used to prepare NASA's Phoenix Mars lander before its launch in 2007. For context, when NASA readies a spacecraft destined for another world, it goes through rigorous cleaning in these specialized rooms, at Kennedy Space Center in this case. The goal is to prevent forward contamination. You don't want to accidentally send Earth germs to Mars, and then later mistake them for Martian life, or worse, have them multiply there. Clean rooms are outfitted with HEPA-filtered air, strict protocols for personnel, surfaces regularly wiped with strong disinfectants, ultraviolet light treatments, you name it. Despite all that, a joint team of NASA and university researchers taking samples in the facility found a shocking variety of microbes. They identified 53 strains of bacteria, representing 26 entirely new species that hadn't been seen before. These weren't contaminants coming off someone's skin that we already knew about. These were novel extremophiles, adapted to the clean room environment. In other words, in trying to eliminate life, we created a niche where only the most hardy, unusual bugs could survive. And they did, even evolving enough to be considered new species. Think about it. A clean room is dry, starved of nutrients, bathed in occasional chemical cleaners, and practically irradiated under UV lights. It's like a desert crossed with a lab. The microbes that managed to live there had to be tough as nails. And indeed, scientists found that many of these new bacteria have traits of extremophiles, the kind of organisms we normally find in very hostile places on Earth, like deep-sea vents, Antarctic ice, or nuclear reactor cooling pools. This was both an exciting discovery, new species, in a NASA lab, and a bit alarming for planetary protection folks. How did they survive? What special tricks do these microbes have? By looking at the genomes of these newfound critters, researchers pinpointed several adaptations. Many of the bacteria had genes linked to high resistance to radiation and oxidative stress. Clean rooms often use UV light or peroxide-based cleaners to kill germs. These microbes basically had enhanced DNA repair mechanisms. So even if their DNA got zapped or chemically damaged, they could fix it better than typical bacteria. They also had genes for detoxifying harsh substances, likely a response to the cleaning agents. Imagine a microbe that can literally eat the cleaning fluid, or at least neutralize it. That's what some seem capable of. Another adaptation was a boosted ability to form biofilms. That's when microbes huddle together in a slimy layer to protect each other. In a tiny crack or corner of a clean room, forming a biofilm could be a smart survival strategy, creating a micro-pocket where they're shielded from the worst of the cleaning and can share nutrients. These biofilms can be really tough to eradicate, even in hospitals, let alone a spacecraft clean area. So essentially, these species are master survivors. They probably endured cycles of near starvation, random cleanings, and long periods of dryness. Each time, maybe only a few hardy cells survived, but those few reproduced and carried on, generation after generation, right under our noses, or under the floor panels, perhaps. Over years, that's plenty of time for evolution to favor any genetic mutations that help them survive the clean protocols. Hence, new species fine-tuned for this weird habitat. Why this matters: planetary protection and future missions. This discovery is a double-edged sword for NASA and other space agencies. On one hand, it's fascinating scientifically. If Earth life can adapt to something as extreme as a spacecraft clean room, it shows how robust and versatile life is. It suggests that if we're looking for life on other planets, we should be open-minded about the kinds of environments that could support microbes. Perhaps Martian life, if it exists, might be clinging on in places as sparse as these clean room analogs. Low nutrients, lots of UV radiation, etc. It even gives insight into what kind of biomarkers or genes to look for as signs of extreme survival. On the other hand, it's a wake-up call. Our best sterilization efforts might not be enough. Those 26 new species in the Phoenix Lander's assembly area, we have to hope none of those hitched a ride on the lander itself to Mars. Phoenix's mission was to taste Martian soil for signs of water and organics. And ironically, it might have carried some tiny stowaways despite all precautions. Now, NASA and international guidelines demand extremely low bioburden on spacecraft going to places like Mars, especially where life might exist. So this study will likely lead to improved cleaning procedures or new techniques, maybe even genetic monitoring of clean rooms regularly, not just standard petri dish swabs. We might need to employ more heat sterilization or specialized antimicrobial surfaces in these facilities. It's a kind of evolutionary arms race. We make it cleaner. Only the most extreme bugs survive, so we have to step up our game again. There's also a flip side: backward contamination. When we bring samples back from Mars or other bodies, we want to make sure Earth life in labs doesn't confuse the results or leak into the sample. Oh, knowing what organisms lurk in our labs helps with that too. If a strange microbe shows up in a Mars sample, we need to tell if it's truly Martian or just one of these sneaky clean room dwellers that got in afterward. With plans for Mars sample return in the works, understanding and controlling Earth, microbes is more important than ever. And beyond space, these findings have cool implications on Earth. Find some of those genes that help bacteria survive intense radiation or chemicals. Those could have biotechnological uses. For instance, enzymes that repair DNA so well might be useful in medicine or in industrial processes to protect organisms or cells we engineer. Or bacteria that consume harsh chemicals could be used in bioremediation of toxic waste. So even though these little guys were a bit unwanted in the clean room, they might turn out to be helpful to us in other ways once we study them. Closing thought. In a poetic sense, finding life in NASA's clean room underscores that life is incredibly tenacious. It will exploit any niche, no matter how inhospitable it seems. As we prepare to explore other worlds, this forces us to be both more careful and more optimistic. Careful, because clearly microbes from Earth can sneak along, even when we try our hardest to eliminate them. And optimistic, because if life can do so well in a near-sterile lab, maybe it's not so far-fetched that microbes could survive on Mars or the moons of Jupiter or other harsh cosmic locales. It's ironic. The better we get at eliminating life, the more impressive the survivors become. It leaves us with an interesting thought. Could we ever truly sterilize something 100%? And if life from Earth is this resilient, what might alien microbes be capable of in their own extreme environments? These questions remind us that in the grand scheme, life, even microscopic life, might be one of the most formidable forces in the universe, refusing to give up against all odds.